Okay, so this is the first lesson from Unit 4. We started Unit 4 today on quadratic equations. So we started with this warm-up, which takes us back to Unit 1. So pause the video, try it, and then play to check your answers. Okay, so we learned in Unit 1 how to shift or translate absolute value graphs. So we know that we're going to have y equals, we have the absolute value, and inside the absolute value, we want up 6 and left 2. So left 2 we know is plus 2, and up 6 is plus 6. And we learned that to create a vertical stretch, we need a number in the front whose absolute value is greater than 1. So something like 3 or 2 or 4, or something like that works. So that is the equation for an absolute value that has a translation 6 up, 2 to the right, 2 to the left, and a vertical stretch. Okay, so next, we took a look at, I gave some notes here on parabolas. So we started with the most basic quadratic equation. And the most basic quadratic equation is y equals x squared. So we first just did a little sketch of that. So if I'm sketching y equals x squared, substituting in 0, I know I get 0. Negative 1 and 1 gives me 1. Negative 2 and 2 gives me 4. And there's a very quick sketch of y equals x squared, which has a vertex at 0, 0. Okay, so the next thing we talked about was that if I wanted to translate y equals x squared, if I wanted to translate that parabola, shift left, right, up, down, the translations for a parabola are almost identical to the translations for an absolute value, which is why we did that warm-up to get you remembering, refresh your memory. So the translations, if I looked at y equals x squared and I want to, let's say, add on a number, k, that would be an up shift. Okay. Similarly, x squared minus k would be down. So then left, right, remember for absolute value, it's inside the absolute value, adding or subtracting. Well, with quadratics, it's inside the parentheses and squared. So x minus h, the quantity squared, would be right h units. And when you write that, you don't want to forget the squared. It's not x minus h in parentheses, it's x minus h in parentheses squared, because it's a quadratic. If you forget the squared, then we're talking about a linear, and that would be incorrect. So then in parentheses x plus h, the quantity squared, that would be left h units. Okay, so those are all the translations that can happen to a quadratic equation. So then we talked about the transformations. Okay, and the transformations are also very similar to absolute value graphs. So I can have a vertical stretch or vertical compression, and I can have a change in orientation to negative. So if I look at y equals ax squared, some number in front of the x squared, if the absolute value of a is greater than 1, that's when we have a vertical stretch. If the absolute value of a is less than 1, that's when we have a vertical compression. And remember, vertical stretch, think about if I'm looking at this graph here, if I'm pulling on the ends vertically, vertically stretch is going to make this parabola skinnier versus like a compression. Pressing down on both ends is going to make the parabola wider. The last thing we talked about is that if a is negative, So if a itself is less than 0, then we have a negative orientation, meaning the parabola is now opening down. Okay, so those are all the different translations and transformations. So we're going to think about doing those translations and transformations to this parabola, to the basic y equals x squared. So take a look at the first example, copy that into your notes. So I see that plus 5 on the end, and I know that that means up 5. So that's the translation. Transformation, well, there's no number besides 1 in front of the x squared, which means there are no transformations. Okay, and vertex, so go back to your sketch of the normal parabola, the most basic one, and if I shift that up 5, it's going to take us here, which has a vertex at 0, 5. Lastly, the domain and the range. So I'm looking at my sketch. Domain, negative infinity to positive infinity. And range, remember we're looking low to high. So the lowest value is 5, and it equals 5. And then it's going towards infinity. So 5 comma infinity would be the range. Okay, so then we just had a couple more to try. So same steps, we're going to list the translation, so that minus 3 before squaring is right 3. That's it for translations. Transformations, we have a few. So first of all, that 1/3 means it's a vertical compression. And the negative means it's a negative orientation or opens down. Okay. So vertex, if it was at 0, 0 is the most basic vertex, and I shift right 3, that's going to take me to 3, 0. Domain. Okay, so we already realized the domain for the last parabola, and if you look at any parabola, whether it's right side up or has a negative orientation, upside down, all parabolas have the same domain, and that is negative infinity to positive infinity. Range, the range will change though. So thinking about this sketch, 3, 0, the y value is 0 for that point, and that point is, the vertex is the highest point because we already said this is an upside down parabola. So if I'm picturing an upside down parabola with 0 being the highest y, then we know that means the range goes from negative infinity, because it's pointing down, to 0, and it does equal 0, so bracket. Next, go ahead and try this one. Pause the video and then play to check your answers. So translations, plus 4 would be left 4, minus 8 would be down 8. So next, transformations, the negative 2 means a vertical stretch, and the negative means a negative orientation. And remember, when you're realizing it's a vertical stretch, that's because we take the absolute value of negative 2, which is 2, and 2 is greater than 1, therefore it's a vertical stretch. Okay, next, vertex. So we said left 4 and down 8. Well, left 4 would take us to negative 4, and down 8 would take us to negative 8. So negative 4, negative 8. Domain, we know, is going to be the same. And range, we said this is upside down, negative orientation. So negative infinity up to the highest point, which would be negative 8. And that it does equal negative 8 for y, so bracket. Next one. So this time I'm giving you the translations and you have to write the equation. Well, we're remembering that left and right, that's inside the parentheses being squared. So I'm going to write parentheses and squared. And I'm going to look here. It says right 4. So if you remember, right is minus. And then it says up 12. So remember, up is after the squared. And so that's going to be plus 12. So that's our equation. Next one. Rewrite y equals x squared to include a vertical stretch by a factor of 2. So we already said the vertical stretch is when the absolute value of a is greater than 1. So we were being told it's 2. So that just means the a value, the number in front of the x squared, has to be a 2. So y equals 2x squared is our equation. And then we're supposed to graph that. Well, I'll just do a real quick table. So -2, -1, 0, 1, and 2. 0 squared is 0 times 2 is 0. -1 and +1 both squared give me 1, and 1 times 2 is 2. And -2 and +2 squared is 4, and 4 times 2 is 8. So we have -2, 8, +2, 8. We have -1 and +1, 2. And we have 0, 0. And that's my sketch. And then we just need to label the vertex 0, 0. And looking at that, it does appear skinnier than the standard one that we graphed at the beginning of class. And it should, because it's a vertical stretch. Next, so if you recall from Unit 1, we also did problems like this with absolute value, where we were given a coordinate point that the graph goes through, and we were given the translations, and we had to write the equation. So if you recall, when we did that, we put an a in the front because we didn't know what the vertical stretch or compression was. We substituted in the shifts, the translations, and we substituted in x and y, and then we solved for a. We're going to do the exact same thing here. However, now it's not an absolute value graph anymore. It's a quadratic, so it's y equals x squared. So I'll start with this equation, which, by the way, we'll talk about this equation more in the next couple of days. That equation is called vertex form. Again, we'll talk about that more later. Really, all you have to know right now is that we're using an a in the front, and then we're going to put the translations in for h and for k, basically so that we have the vertex there. And then we'll substitute x and y in. So I know that it says left 3, so we know that means plus 3, the quantity squared. And then I see down 6, so I know that's minus 6. So that's my first step. Now I'll put the coordinates in, -5 in for x and -26 in for y. I don't know a, but I do know -5 is x. That's the quantity squared. Don't forget the squared. So we have -26 equals a times -5 plus 3 is -2. -2, the quantity squared. -2, the quantity squared is 4. 4 times a is 4a. So I'm going to add 6, which gives me -20. I'm going to divide by 4, which gives me -5. So we have our equation y equals, remember, we're coming back here to this step and substituting the a value in. -5 times the quantity x plus 3 squared minus 6. That's our equation in what we call vertex form. Okay, and then looking at that, I can see that the -5 means this graph has been transformed, has a vertical stretch, and it also has a negative orientation. And I can tell that by looking at that a value. Last example for today. This one I had the students try in class, so you can pause the video and try it and then check your answers. So same idea, y equals a times parentheses x. We're seeing right 1, so -1, the quantity squared, and then up 2, so plus 2. Substituting in 18 for y and -7 for x. Simplifying that, so a times -7 minus 1 is -8, the quantity squared plus 2. So order of operations, exponents. First, negative 8, the quantity squared is 64. 64 times a is 64a. Next, subtracting 2 gives me 16. Dividing both sides by 64, so I have 16 64ths, which we know simplifies to 1/4. So we have our equation, y equals 1/4 times the quantity of x minus 1, the quantity squared, plus 2. That is our equation. And again, looking at the a value, we can see that this graph has been vertically compressed because of the 1/4. Okay, that takes care of our lesson for today. So homework tonight in the new packet, which if you weren't in class, you'll have to get one of those or you can print it off from Schoology, pages 1 and 2 in the new packet. And in the worksheet booklet, remember, we're now in Unit 4, so Unit 4 worksheet number 1, just the first 6 problems, 1 through 6. Unit 4 worksheet 1, problems 1 through 6, and pages 1 and 2 of the new Unit 4 packet. Do those for tomorrow.